Hey devs, and welcome back to week 8 of our ongoing Android development course. This week, we're going to be refactoring Forecast Details Fragment to take advantage of some of the new features coming out of Android Jetpack. We're going to make use of a ViewBinding to remove all of the calls to findViewById within that fragment. We're going to make use of the Android Architecture Component ViewModel to format and manage our UI data, and to persist that data across configuration changes. So by the end of this week's assignment, you should have a basic implementation of MVVM within your forecast details screen. This will demonstrate to you how separating your code into these separate layers can make it smaller, easier to work with, and more extensible as you were to build this out into a more fully functional app. All right, let's jump into our lecture for this week, where we're going to be talking about ViewBinding, the Android Architecture Component ViewModel class, and a general MVVM architectural pattern. So we'll go over a quick project overview. What are we building this week? Then we'll talk a bit about ViewBinding and how we can use it to replace calls to findViewById. We'll then introduce the Android Architecture Component ViewModel and talk a bit about MVVM and how we can use the ViewModel in that architecture. And then finally, we'll wrap it up with a brief overview of ViewModel scoping and how we can use ViewModel scoping to save data across configuration changes. So for our project demo, now for the last 8 weeks or so, this would be the point where I would jump over to the emulator and walk through the new functionality we're adding. However, this week, the app looks pretty much exactly the same. We're not updating anything to the UI this week. All the changes are going to be kind of internal, more of how we're structuring our code. So this week, we're going to be focusing exclusively on refactoring Forecast Details Fragment in a few different ways. We're going to use ViewBinding to replace all of our calls to findViewById. We're going to introduce the Android ViewModel class and use that to implement a simple MVVM architecture within Forecast Details Fragment. And then finally, we're going to save data across configuration changes by using ViewModel scoping and reusing existing ViewModel data when the fragment and the device is doing things like rotating around. So let's jump into ViewBinding. What exactly is ViewBinding? So ViewBinding is really a new feature, new functionality within Android, really sort of becoming popular in the past year. And effectively what ViewBinding does is it's a compiler option that will generate statically typed view references for us. And this essentially removes any need to call findViewById. Within an activity, or in this case, a fragment, we can get a reference to a binding class for a particular layout. So for our forecast details fragment, for example, we have a layout called fragment forecast details.xml. Once we've enabled ViewBinding, that XML gets converted into a binding class that has a very similar name. So instead of fragment forecast details.xml, we get a binding class called fragment forecast details binding. We can then inflate that binding very similarly to how we would inflate a fragment layout anyways. We call inflate, we pass in the layout inflator, the parent container, and false generally because we don't want to add it to the parent automatically. Once we have the binding class, this is where the real magic happens. Any view within the layout XML that has an ID property will have a property added to the generated binding class. We can then reference those views using the binding class. So in this case, we call binding.descriptionText to get access to the text view in our fragment layout with the ID of description text. And similarly for date text or for the forecast icon. And so because we have this generated binding class, we don't need to look up the views using findViewById. And where this is really nice is that it gives us compile time safety. If for some reason we remove a view but don't update our code, we're going to know about it because it won't compile anymore. Whereas before, if we're using findViewById, that check is done at runtime, and it might cause us to crash when we try to inflate that view at runtime. So now, like I mentioned, this is all happening with a compiler option essentially that's generating this code for us. And we enable that in our apps build.gradle file. So within the Android configuration block, we add this view binding configuration and set enabled equals to true. Once you've done that and done a sync and maybe a rebuild on your project, when you have layouts, it should generate these binding classes for you based on the XML. Now, our next topic for the week is ViewModel, specifically the ViewModel class from the Android Architecture Components. And this week, we're going to be looking at how we can use the ViewModel to help us separate business logic from the UI presentation logic within our app. Now, the kind of official definition of ViewModel, I think, is actually pretty good here. So we're just going to take a look at that. The ViewModel class is designed to store and manage UI-related data in a lifecycle conscious way. The ViewModel class allows data to survive configuration changes, such as screen rotations. We're going to look at that example. So basically what this is saying is the ViewModel is a good place to basically decide what needs to be on the screen, expose that data to your fragment or your activity, and then because the ViewModel is responsible for handing out that data can then survive configuration changes such as rotating your screen, meaning that you don't have to reload data anytime the screen is rotated or any other number of configuration changes happen. So this is a really nice win for us because it helps our apps be more efficient, require less network usage, etc. So with the ViewModel, we can do a number of things. We can use it to manage our data sources. It might have multiple repositories and it pulls data in from all of them, combines them all together, and then it might format that data. So it might take in a date timestamp and turn that into a displayable date. It might build up an icon URL based on some type of code or convention in the API. The ViewModel then helps us save data across configuration changes. We can then expose that data to be displayed in the UI using something like LiveData, so that the UI will only be updated when it's active, but the ViewModel can update itself independent of needing to know about the fragment and what state it's in. Now, the ViewModel lends itself pretty well to implementing the MVVM architectural pattern. Now, if you aren't familiar, MVVM stands for Model View ViewModel, and its goal is to help us separate business logic and UI presentation logic. Currently, we have really all of our logic within the fragment. So it means we're loading some of our data or getting access to the data in the fragment. We're then formatting it there and binding it into the UI. And in small screens and small projects like ours, that's usually not too much of an issue. But for larger code bases, production code bases, that quickly becomes unmanageable. And if you want to scale your app properly and have it be maintainable, have it be easy to work with, it's good to separate that logic out because it gives you clearly defined boundaries as to what types of code to put where. It makes it easier to debug issues. It makes it easier to add code. It's just a good practice all the way around. So in MVVM, you have these three components. You have a view, a ViewModel, and a model. And these are all kind of abstract. It's hard to know exactly what's going on here. So in our case, a little bit more concretely, the view layer in our case is going to be the fragment. We're going to work to make the fragment do as little as possible so that the majority of all the logic and the thinking behind what's going to go onto the screen is done elsewhere. Now, the ViewModel is the place where that's really going to happen. We're going to take in the arguments, the data that we need, format it in the view model, and then expose it to the fragment using LiveData. And then in more complex examples, the model layer, that could be everything in like your repositories. That could be your databases, your network services. All the stuff that is actually fetching the data could be considered in the repositories. And so data usually wants to flow between these layers in very distinct ways. Your view model is likely going to be getting data from the repository, and then it's going to expose data to the fragment. And now the fragment might need to send events back to the view model like, hey, I clicked a button. And then the view model might need to respond to that by going out to a repository or a service and saying, get me some new data, or make this network request. So the idea here is to give you clearly defined patterns and clearly defined layers with which to structure your code. Now, once you've put all of this new code into your view model, we want to make use of view model scoping to make sure that we're reusing data. And the reason we want to do this is that we want to avoid creating new view models and thereby loading additional data in response to things like configuration changes. Now, we haven't talked too much about configuration changes in this course, but a configuration change is something like a device rotation, for example, where you're going from portrait mode to landscape mode, or maybe vice versa. Because this might require a new layout to be loaded, we get a configuration change. And by default, a configuration change usually means that the entire activity is destroyed and recreated, and thereby fragments destroyed and recreated. So if you don't take advantage of view model scoping, what'll happen is you'll create a new fragment, then a new view model for that fragment, and you'll load the data all over again. If you have expensive data, meaning it takes a lot of network bandwidth, it takes a lot of database time to load, this then becomes really expensive and is hard to manage and leads to poor user experiences. So we want to reuse our existing view models, and we can reuse those within a couple different scopes. And when I say scope, essentially that defines how long the view model will stay active. So for example, you could define a view model scope that says, for as long as this fragment is on the screen, this view model will be active. Or you could say, for as long as this activity is alive, we're going to reuse the same view model. So anytime someone asks for a particular type of view model, we'll hand back the same one. And similarly, you could do the same for a navigation graph. Now, like I said, what this does for us is it helps our apps be more responsive. We make fewer network requests, database requests, and an overall better user experience. And we're going to see step by step how to combine all of these things to really make our code here easier to manage and more performant. You're going to see that the fragment becomes much less code. The view model becomes very clear how it's taking in data and then formatting that and exposing it to the UI. And we'll take advantage of view model scoping so that we're not reloading and reformatting data when the device is rotated. And so with that, we'll go ahead and jump over to Android Studio and dive into our code updates for the week. Okay, so we're going to start off this week by taking advantage of the ViewBinding functionality that has been newly added to Android. So to do this, we're going to open up our apps build.gradle file. Now within this, we need to configure a build option for our Android app. So within this build.gradle file, we'll find the Android block here. Then we'll scroll down to the bottom, and below where we have configured our Kotlin compiler options, we're going to hit return, and we're going to type ViewBinding followed by an open and closed curly brace. And then we're going to type enabled equals true. So this should go ahead and enable the ViewBinding a compiler option within our project. And this is going to generate binding classes for us from our layout files. So after we've updated this, we're going to be prompted to sync our Gradle file once again. So we'll go ahead and hit sync. Then we're going to want to open up forecast details fragment. And now this week, we're going to be working on refactoring forecast details fragment to take advantage of ViewBinding. And after that, we're going to refactor this to make use of an MVVM UI architecture pattern. So now that we are in the forecast details fragment, we want to make use of the binding class that the ViewBinding compiler option generates for us. So to do this, we're going to start off by creating a couple of new properties to manage our binding class. And this is going to follow the pattern very similar to that we've used for managing LiveData in some of our repositories. We're going to have a private internal binding option, and then we will have more of the public-facing one that we want to be a part of our main API for this class. So to start, we'll type private var underscore binding colon. Now for the type, we want to access the binding class that was generated for the fragment's layout file. So to do that, we'll type fragment forecast details binding. And then this is going to be a nullable type. So we'll add the question mark, and then we'll initialize that to a null value. Now we're going to create the non-null property that we are going to take advantage of when we want to use the binding in the fragment. And so to start, we're just going to leave a little comment here that says this property only valid between on create view and on destroy view. And we'll talk a little bit more about why we want to add this comment and what it means in a moment. So after we've added the comment, now we can type private val binding. And now we're going to add a custom getter for this property by typing get open and closed paren, then an equal sign underscore binding. And now we're going to add a double exclamation point here. And the reason for adding the double exclamation point is because it will enforce the type of the binding property to be non-null. So to illustrate this, we'll come back to our binding here, and we're going to once again make use of the fragment forecast details binding type. Once we've added that type, we'll see that we have this error on the underscore binding assignment. This error is basically telling us we have a mismatch. It's saying that we have requested a non-null binding property, but we've passed in a nullable binding property because underscore binding is a null type. Now, as we've pointed out in the comment, we want the binding property to be valid only within certain lifecycle methods of our fragment, because that's when we expect the view to actually be available and be valid. So that's why we have these two properties. We have the underscore binding that represents the fact that this might be null throughout the entire lifecycle of the fragment. And then we have the non-null binding property to represent the non-null expectation of that property within the onCreate view and onDestroy view lifecycle. So to enforce binding being non-null, we're going to assign underscore binding and we add double exclamation point because that will throw an error if for some reason underscore binding is null at that point. So we're just going to go ahead and remove the explicit type there because it can be inferred automatically. Now that we have our binding class or our binding property set up, we want to actually make use of that binding. Now, ultimately, using this binding class is going to let us replace all of our calls to find ViewById within the onCreateView method of our fragment. To start, we're going to make use of the binding class to replace the call to the layout inflator. So we'll come into onCreateView and we're going to delete the first line here. And instead, we're going to update it to assign underscore binding equals fragment details binding dot inflate. Within the inflate call, we're then going to pass in the layout inflator, the container, and we'll pass in false. So this actually looks very similar to the way we were inflating the layout before. So now this has given us access to the binding object. We need to come down to the bottom of onCreateView, and instead of returning layout, now we're going to return binding.root. Binding.root is a property available on all the generated ViewBinding classes, and root essentially just gives you the root view. It returns you back the whole layout. So now that we have initialized our binding property within onCreateView, we need to clean it up in onDestroyView. So I'm going to hit return a couple times, and we're going to add an implementation of onDestroyView. To do that, I can simply start typing on destroy, and it should give you several methods to choose from. So if you select down to onDestroyView and hit enter, it should generate that implementation for you. So now hit enter, and below the call to super.onDestroyView, we're going to type underscore binding equals null. So this will just work to ensure that we are clearing the reference to the binding, because we want the views to be cleaned up in memory when they are destroyed. This will help us prevent memory leaks and help us keep our app performant. So now for the fun call in our, now for the fun part of using ViewBinding, we're going to replace all of the calls to findViewById. So I'll simply come up here and then onCreateView. I'm going to highlight all of those calls to findViewById and simply delete them. Now we're going to have a number of errors here because we're trying to assign data to view elements that no longer exist. So you can see here, I have a unresolved reference to temp text. So the way to fix this is to use our binding property. And remember, we're going to use the non-null version because within onCreateView, until it's destroyed, we can expect binding to be non-null. So I'm going to type binding dot, and as soon as I do that, the reference resolves. So how is this actually working? Well, if we open up our layout, fragment forecast details, if we look at the XML, you'll see here that for each view, we have added an ID. So if we look specifically at temp text, you'll see that we have an ID of temp text. If we come back over to our fragment, we'll see that matches exactly the property on the binding class. So for every XML layout element in your layout, the binding class will generate a property as long as that view element has an ID on it. So if we come back to our fragment, we can finish updating these references. So I will type binding dot description text, binding dot date text, binding dot forecast icon. And so now we no longer have any calls to find ViewById. And if we deploy our app, it should look just the same as it did before. So I will quickly enter a zip code, click submit, and then I will load up some forecast details, and there we go. It looks exactly the same as it did before, but we have now successfully integrated the ViewBinding library. Now that we've integrated ViewBinding, let's work on implementing an MVVM architectural pattern into our app. To do this, we're going to make use of the Android Architecture Component's ViewModel class. The ViewModel will serve as our place for loading data and defining the view state that should be bound to our UI. This will help us persist data state across configuration changes such as rotating the device. To do this, we're going to start by opening up our app level build.gradle file over on the left-hand side of the screen. We're going to scroll down to the bottom, and in the dependencies section, we're going to enter in right below the navigation dependencies, and we're going to add the dependency for the ViewModel class. To do this, we'll start by typing implementation, then we'll add double quotes, and we'll type AndroidX dot lifecycle colon lifecycle dash ViewModel dash KTX colon 2.2.0. Now, as always, after we've added our dependency, let's go ahead and do a resync to make sure we have entered the dependency correctly. And if the sync completes, we should now be able to make use of the ViewModel class. So to do that, let's start by opening up our forecast details fragment once again. So we're going to make use of a new ViewModel for forecast details fragment. We're going to use the ViewModel to format our data, and it is going to then expose data using LiveData, and then within the fragment, we will observe the live data and update our UI. So to start all of this off, we're going to come to the project pane on the left-hand side of the screen. We're going to right-click on the details package, go to New, Kotlin file or class. Then we're going to select class, and for a name, we're going to call this forecast details view model, and then hit enter. Now this should generate a class for you, and then we're going to extend ViewModel by typing colon ViewModel. Now this should start off as an unresolved type, and it should prompt you to import that type. To do that, we can type Alt Enter, and it should add the proper import for you. And just to double check, make sure that you have import AndroidX.lifecycle.viewModel at the top of your file. Now ViewModel has a constructor, so we need to go ahead and add open and closed parentheses. And now we have a fully functional, although very empty ViewModel. Now we can go over to our forecast details fragment, and underneath our args property, we can go ahead and start using the ViewModel by typing private val ViewModel equals forecast details ViewModel. So for now, this is just really a placeholder to signify that we will eventually be getting a reference to this ViewModel and using it in the fragment. However, for now, we're going to go back over to forecast details ViewModel and start working on implementing the live data that we want to expose that will represent what we want to show on the screen. So we're going to create another class here by once again going to the project pane on the left-hand side of the screen, selecting details, right-clicking, going to new Kotlin filer class. We'll select class, and this time we're going to name the class forecast details view state and hit enter. We're going to make this a data class by adding the data modifier at the end. And now we're going to add open and close parentheses, and then we're going to define the fields that we want to store in this forecast details view state. This will represent the data that we're ultimately going to display on the screen. So what data do we want to put in here? Well, if we open up our fragment, what data are we setting into the screen? We have a temperature value, we have a description, we have a formatted date, and we have an icon URL that's being loaded. So those are the values that we're going to add to our view state. So we'll start by defining val temp of type float. Then we'll add val description of type string, val date of type string, and val icon URL also of type string. Now let's go back to forecast details view model, and we're going to make use of this new view state type. And we're going to follow the same pattern we've used in our repositories for working with LiveData. So we'll come within the class body. I'm going to start off by typing private val underscore view state colon mutable live data. Once you've typed mutable live data, it'll prompt you to add the import. You can hit Alt Enter to automatically add that. Once again, at the top of your file, make sure it's imported the proper thing. You should see androidx.lifecycle.mutable-live-data. Now, after the mutable live data, we have this open and closed angle bracket. This is asking us for the type that this live data will expose. So this is where we're going to make use of that new view state type. Forecast details view state. So this is signifying that our live data is going to send out new instances of forecast details view state for the fragment to observe. And then finally, we will initialize this by saying equals mutable live data with an open and close parentheses. And so now, as we've done in our repositories before, we're going to create a public property that mirrors the private one. We'll type val view state colon live data. And again, we'll have to import the live data type here. So I'll hit Alt Enter, and it should add the import for androidx.lifecycle.livedata. We're also going to expose a forecast details view state. And this time we will say equals underscore view state. So this will let us configure our state, expose it via live data, and let the fragment bind it into the UI. This keeps a nice separation of concerns between the business logic of formatting and combining data and the UI logic of placing those individual values into the views. So now that we have this basic live data setup, let's go to the fragment and work on observing this data. So to do that, we're going to come down here, and right below on Create View, we're going to add another fragment lifecycle method here. We're going to observe the live data using a lifecycle method called onViewCreated. So I typed onViewCreated, hit enter, and it pre-populated this implementation. OnViewCreated, as the name suggests, is going to be called right after onCreateView. So at this point, our view will be set up. Eventually, our view model will be all set up. And this will be a nice, safe place for us to observe changes in the UI and then ultimately update that UI. So now we'll come below super.onViewCreated, and we're going to start off by creating a live data observer to observe changes in forecast details view state. To do that, we'll start off by typing val view state observer equals, and now we're going to start typing observer. And we want to make sure we're careful here because there are a number of different observer types available. We want to make sure that we select the observer coming from Android X.lifecycle. So for me, I've scrolled down to what is the fourth one for me, and I've hit enter. Now this type is going to expect a templated type to indicate we want to listen to forecast details view state. So within the angle brackets, I'll type forecast details view state, and then I'll add open and closed curly braces. Within the curly braces, I want to rename the it parameter so that it's easier to understand that we're working with a view state. So after the open curly brace, I'll type view state followed by a dash and then a closed angle bracket for our lambda arrow there. Now within this, eventually we're going to update the UI. And for now, I'm just going to leave that comment there because we're not quite ready to do this yet. Now, after we've defined our observer, we want to actually observe the values. To do that, we'll type ViewModel.ViewState.observe. Now we need to pass in a lifecycle owner. So we'll do that by typing view lifecycle owner, comma, and now we can pass in our view state observer. So now when onViewCreated is called, we will create this new observer and we'll start observing changes to the view state. So now the next thing we need to do in the migration to MVVM is to move the business logic of formatting our date from the fragment into the view model. To do this, we need a way to get the fragment arguments into our view model. Currently, we're calling things like args.temp, args.description, using the args property on our fragment. If the view model is going to handle the same types of formatting, we need to get that data then to the view model. Now, there are a number of ways to do this, some that might be considered cleaner code. However, some of those ways are also a bit more complex. So we're going to start pretty simple. We're going to add a method on our view model called processArgs. So I'll open up our view model class here. And I'm going to create this new method by typing fun processArgs. Now, as a parameter to processArgs, I'm going to create a parameter called args:, and I'm going to make it be of type forecast details fragment args. So those args that we get from the fragment, we're going to then just pass that into this processArgs method. So now within this method, we will convert the passed arguments into a formatted view state. To start, we're going to assign the view state a new empty view state. So we're going to say underscore view state equals forecast details view state with an open and closed parenthesis. So now we're going to need to define each of the properties on that data class. So to start, we're going to use a named parameter syntax here, so it's very clear what we're doing. So we were going to assign temp equals args.temp. Then we're going to add a comma. Then we're going to say description equals args.description. Now the next thing we want to do is the date. However, if you remember in forecast details fragment, we're actually doing some formatting of the date. We're using this date format class, and then we're passing in some extra logic here for converting the date from milliseconds into the proper time. So we need to move all of that logic into the view model. To start, we're going to copy the date format top level property from forecast details fragment. We're then going to delete it from the fragment and add it back within the forecast details ViewModel file. So now we have that format available. Let's come back to our fragment and we're going to copy the line here again that is formatting the date. So I'll do a copy and then I'm just going to add that and paste it within our new method here. And that's all we need to do for formatting the date. It's the same logic, it just now lives within the view model. And now for our last property on the view state, we need to create the icon URL. Now, just like the date, we're doing some processing for the icon URL. We have this string here that we're passing into the call to forecastIcon.load. So again, we're going to copy this, go back to our forecast details view model, and then paste that in to the assignment here. Now, we see that we have this error here. What is the problem? Well, remember, we need to assign the value of the live data as opposed to the whole live data itself. So we'll come back to _viewState and add .value. So now this is saying, okay, we are creating a new instance of forecast details view state, and we want to assign it as the new value for our live data. When we do that assignment, it will then update the observer in the fragment, and that observer can then use that to update the UI. So let's go ahead and make that update now. We'll go back to forecast details fragment, and we're going to work on moving the logic out of onCreateView and into our observer in onViewCreated. So let's come down here to the observer underneath our comment to update the UI. And we're going to start by adding our temperature text. So just like before, we can type binding.tempText.text equals, and now we're going to use the view state. So we'll get the updated view state by typing viewState dot, and now we want to use the temp. However, if we just use viewState.temp, we have an error. ViewState.temp is a float, whereas temp text is expecting a string. So we need to do the same type of formatting that we are doing in onCreateView. So we're going to come up here and again copy this line. This is format temp for display. And we're going to add that down here within our view state observer. However, instead of passing args.temp, we're going to pass viewState.temp. Now, for our next UI element to update, we'll type binding.descriptionText.text equals viewState.description. Then we will say binding.dateText equals viewState.date. Then we'll say binding.dateText.text equals viewState.date. And lastly, we will load the forecast icon. So we'll again use binding.forecastIcon.load, and then we will pass in viewState.iconURL. Now, once we've done this, we can come back up to onCreateView and remove these old calls to the binding class. And now we'll just go ahead and clean up some of the spacing just to reduce the amount of code we have here. And so now let's talk through the flow here again. When our fragment is created, we're creating a new instance of a forecast details view model. In onCreateView, we're getting a reference to our binding class. In onViewCreated, we're adding an observer that will listen to changes in view state coming from the view model and then update the UI based on that new view state. If we go ahead and rerun this, we can now see how this is looking. So if we come over to our Week tab, open up Forecast Details, you'll see that we have an issue here. We only see the icon, and really the icon is only displaying the placeholder. So what is the problem here? Well, if we look at our code, we've set everything up to respond to changes in view state. However, we haven't actually updated our fragment to make use of the process_args method that we previously created. So what we can do is in onViewCreated, after the call to observe, we're going to add ViewModel.process_args, and we will pass in the args property of our fragment. So now we should get that initial processing, which will give us an initial state, and we should now see the data in our UI. So if we rerun this one more time, now when we go back to our emulator and view details, we see the forecast details that we would expect. Okay, so now we've returned back to forecast details fragment here. And now we need to take a step back and think about where we're at currently. We've moved a lot of the business logic into our view model. The view model then is responsible for formatting some of that data and then exposing that back out as a view state. And then that gets used to update the UI. So this is nice. We have a much cleaner separation of concerns. The fragment is responsible for binding data. The view model is pulling in data and formatting it properly. So this is a nice win. However, we currently have a subtle issue here. If we look at our emulator, if we were to rotate the device, what would end up happening is that we would actually be creating a new view model each and every time we rotate the device. This is very not ideal because it means that we are instantiating new objects when we don't need to. Now, in a simple screen, this is not really much of an issue. However, imagine we're in a more complex screen in which you're making network requests, loading from a database, or other more intensive actions. We wouldn't want to throw away any loaded data if we didn't have to. Ideally, we could reuse the data that we have already loaded or that we are in the process of loading, and then rebind that data to the new fragment's view when it's recreated on rotation. Now, to actually implement this, we can take advantage of something known as view model scoping to avoid recreating our view model within a specific scope. So a view model scope basically is this concept of, for as long as the fragment is alive, we're going to use the same view model. Or for as long as the current activity is alive, we are going to use the same view model. So what this lets us do is persist our data across configuration changes like a device rotation, and then reuse the data that has already been loaded. And thankfully, taking advantage of this scoping is actually quite easy, and we're going to see how to do that right now. So if we look at the top of forecast details fragment, remember here we previously instantiated our view model by just adding a new property and instantiating it as a new instance of that view model class. To update this, to take advantage of view model scoping, we can make use of a property delegate available within the Android KTX lifecycle functionality for view models. So we'll delete the explicit initialization and we're going to add a colon forecast details view model to specify the type. And then we're going to type by view model. And now we're going to be asked to import the view models delegate here. So again, I'll hit Alt Enter. And now you want to make sure that you have the proper import once again. So scroll up to the top and make sure that you see androidx.fragment.app.viewModels. Now what's actually happening here? Well, the by keyword here lets us know that we're going to be using a delegate. Basically, a delegate is a software architecture pattern where we're saying we're going to defer some piece of functionality, some lookup. We're going to defer something to this other class. So in this case, ViewModels is a delegate. And if we click into this, there's actually some pretty scary looking code that we're not going to go too far into. But basically, at a high level, this ViewModels delegate can manage a producer and a factory for us. What those two things are going to do is essentially hand us back a view model that is automatically saved and cached for us when things like screen rotation happen. So all of that to basically say that by adding this by view models delegate, we're now not going to create a new instance of our view model every time the screen is rotated. So by adding this, we're no longer creating a completely new view model every time we create the fragment and every time it is rotated or other configuration changes that might cause the fragment to be recreated. So this is a nice win. However, we're still duplicating a little bit of work. If we look at our view model class and we look at our process args function, this is still being called every time onViewCreated is called. And every time we call process args, we're creating a new instance of the view state, even if our LiveData already has a valid view state. In our specific example here, this is wasteful because we can expect the args to be the same if there's already a LiveData. So we can't have a LiveData without already processing the args. And if we don't expect the args to change, there's really no reason to recreate that view state for the LiveData. So ultimately, this means that if our LiveData already has a value, we can skip updating the LiveData. So if we come into process args here, we can add a simple check here that says if view state dot value does not equal null, return. And then I'll hit and enter just to space it out. So now in forecast details fragment, if the screen has been rotated, which caused our fragment to go back through its life cycle, we're once again going to call process args. However, because our view model was retained across the configurations change, because we're using that by view models delegate, our view models view state is already going to have a value. So there's no need for us to create a new one, and we'll just skip and the view data will automatically be bound to the screen. So to test this out, let's go ahead and rerun our app one more time. And if we go back to our details and we start rotating our device, we see that we are getting data each time on rotation without any issues. Now let's go back to Android Studio. Now there's one thing I want to point out here, which is that this is pretty specific to our example, the fact that we can get away with this check and process args. Ideally, the args would actually be passed to the ViewModel constructor, and we wouldn't even need this type of process args method. And the reason we want to avoid a method like this is because it introduces this potential for duplication of work. It also means that process args could be called multiple times for multiple locations. And really all we want is to say, create a view model, and here's everything you need to make it work up front. And then we don't have to worry about that data changing. It's really getting towards the idea of immutability. We don't want things to change unexpectedly for us. So there's one more change we can make to how we are initializing our view model to help with this process. And to do that, we're going to make use of a ViewModelFactory. So we're going to go to the top of our forecast details view model class here. We're going to hit enter a couple times, give us some space to work. And we're going to create a new class called forecast details ViewModelFactory. So we'll add class forecast details ViewModelFactory. Now within the constructor, we're going to add a property called private val args : forecast details fragment args. So remember, we want to be passing these args into the view model. So we're going to pass them first into the factory, and then the factory will use them to create the view model. Now this forecast details view model factory will extend ViewModelProvider.Factory. Now we'll need to make sure we import the ViewModelProvider class. That should add an import for AndroidX.lifecycle.ViewModelProvider at the top of your file. And then I will add some open and close curly braces. And now to finish out the implementation of this, we need to implement a method called create. Now create is kind of a scary looking method here. So I don't want you to worry too much about the details here. Basically what this is saying is we want to create some type of generic type with this method. And so it's up to us to make sure that the type that's being created is specifically our forecast details view model. So within this create method, we're going to do just that. We're going to make sure we can create the proper type and then return that view model if we can. So we'll say if model class dot is assignable from forecast details view model : class.java, return forecast details view model, and then we will pass in the args. Now we see an error here because we don't currently have a constructor for our view model that takes in the args. So let's just quickly add that to the view model. We'll come down to forecast details view model. We'll add a primary constructor by adding the open and close parentheses. And we'll type args : forecast details fragment args. Now we will update the view model to use those args in just a moment, but for now we'll come back up to our factory and we need to finish this return statement. The return statement is expecting a generic type here. So we have to do this little trick and add as t after the instantiation of our view model. All this is really doing is making this return as a generic type so that this generic factory method is happy. Like I said, don't worry too much about this. This is some more advanced stuff. But the important part here is that we are calling is assignable from forecast details view model. So that makes sure that we can create the view model. And once we've checked that we can create it, we create a new instance of it and we return it. Now, after the if statement, we're going to add a call that basically will throw an exception if the previous statement fails. So we'll add throw illegal argument exception, and for the message, we'll put unknown view model class. So if for some reason our factory fails to create the view model we expect, we'll get this exception giving us a pretty hopeful message that should help us figure out what's going on. So now let's make use of this factory. We'll go back to forecast details fragment. Now let's find our view model property here. And then we're going to go to the line above, hit enter a couple times, and give us some space to work. So we're going to start off by creating a private late init var called ViewModelFactory of type forecast details ViewModelFactory. Now, down in onCreateView, after we've initialized our binding class, we're going to assign ViewModelFactory by creating a new instance of it. So ViewModelFactory equals forecast details ViewModelFactory, and we'll pass in the args. Now we'll scroll back up to the top and we can update the initialization of our view model. So we'll come towards the top to our byViewModels delegate call here. Within the parentheses for byViewModels, we're going to hit enter, and we're going to use named parameter syntax to specify a factory producer. For that factory producer, we're going to pass in a lambda, which we can do by adding an open and closed curly brace. And within the lambda, we're going to simply pass in our ViewModelFactory. So what this has now done is it's now said that when the byViewModels delegate does its magic behind the scenes to create a new instance of our view model, it's going to use our ViewModelFactory to do so. So it's still going to give us the nice caching that we hope so across configuration change, but it's now going to be able to pass in the arguments to the constructor of the view model. So now we can come back to forecast details view model, and we can actually remove the logic here for initializing the view state value. We can remove that from process args. And now we're going to create a new init block. Now remember, a init block's essentially like a constructor. So when this view model is run, this init block will be run. And when that init block is run, we are going to use the args that were passed into the view model to create a forecast details view state and set it into our live data. And so now process args is essentially empty, and we can just go ahead and remove that. And if we go back to our fragment, we can remove the one usage of process args. And now, if we redeploy the app one more time, we'll again see that we see our forecast details, and as we rotate the device, we still have those nice forecast details. So with this, you've now implemented a basic MVVM UI architecture into your app using LiveData and ViewBinding. And you've taken advantage of view model scoping to make sure your data is not being reloaded across device configuration changes like screen rotation. This is a big win towards adhering to Android best practices and for just making your apps efficient and responsive for your users.